for the recording? Fine, thank you. So, morning, boys. Now, explain this activity once again. Yes, Moinuddin. Hello. Boys, can you hear me? Hello. Hello. Can you hear me, boys? Hello. Chaimam, can you look into the matter? Something wrong? The children are not able to hear me? Hello. 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 Boys, can you hear me?
Yes, ma'am.
Hello. What happened? I mean, there was no sound, so I left myself. Can
Ma'am,
you hear me now?
recording has started.
Recording has started, I know. But I'm redoing it because I could not hear you people.
Okay, ma'am.
I'm starting it again. So, well, I wish all of you to, any of you can explain this activity. Can any of you explain this activity better? We have already done, you agreed that we have already done it. I think we did it yesterday itself. So, could you please explain in the 2 or 3 lines what it is all about? Say better. Can anyone explain? What is it? What is this one? What is this better? Hello? Do you hear me or not? Boys? Hello, boys, can you hear me? Hello?
Yes,
Hello?
ma'am.
Then answer me. I'm asking, what is this? This is a pipe, isn't it? This is a pipe. What I've done? I've kept the pipe, okay? And at one end of the pipe, either I have a bell or I have a table clock, right? What do? I keep another pipe in such a manner that I can hear the tick tock of the table clock or the chimes or the rings of the bell properly by putting the ear over here from the other end. We are not concerned about these. ends, but we are concerned about the other end, this one. And accordingly, we will adjust the pipes. What we find that angle I is equal to angle R, isn't it? You agree? Angle I is equal to angle
Yes,
R. We
ma'am.
find this
Yes.
because if we put the pipe here, now where do I have to put the pipe? I have to put the pipe, the other pipe, over here, isn't it? Likewise, if I put another pipe here, then I have to put this over here. You got it?
Yes,
So what
ma'am.
does it suggest? Again, angle I is equal to angle R. So what is the first law of sound? That angle I is equal to angle R. That's the first law. Secondly, the incident ray, reflected ray, and the normal are on the same plane. This is the second law of sound. Both laws are similar for light as well as sound. This is what I had to ask you. That's it. Was it so difficult, better to explain? See, you have to let yourself out. You
No,
have to let
ma'am.
yourself out. Until unless you try, you cannot get the confidence. Why I'm asking you? You may do wrong, doesn't matter. But you will develop confidence that yes, I can speak. Reading is not a big deal, but to speak in your own words is important. That's the reason that why I'm asking all of you. Do you understand
Yes,
now? Do
ma'am.
you understand why I'm asking you again and again? Whatever you
Yes,
speak
ma'am.
in your own words. So gradually you will develop confidence. It's not that overnight you will get it. No, it takes time. But then you have to take the step.
Okay, ma'am.
I can say, but you have to take that action, isn't it? I cannot take
Yes.
action for you. Can I take action for you, beta?
No, ma'am.
I can only say, better you do it. But who has to do? You have to do it.
Yes, ma'am.
So that's it. Hope you understand what
Yes.
I'm trying to say.
Yes, ma'am.
Read better.
And can I read
Yes,
Nurani
start.
Mohammed
Yes, better.
uses of uses of multiple reflection of sound. Number one, megaphones, horns, musical instruments like trumpets, shehnais, etc. are designed to send sound by
Designed.
multiple
Designed.
designed to send sound by multiple reflection in a particular direction without spreading in all directions.
That's it. So megaphones, the huge phones, remember? They hold it with their hand. It's sort of a loudspeaker. It looks like a loudspeaker, but actually it is a megaphone. Then you have horns in the auto rig, in the lorries, in the trucks. Then you have musical instruments like trumpets. I will be showing you how does it look like. Cinemas, they are designed in such a manner that sound is produced by multiple reflection in a specific direction. So I can hear it properly. But if it spreads in all direction, do you think I will be able to hear it properly? Because the sound will be diffused. When sound is going in a particular direction, the sound clarity is maximum. I can hear it properly. But if the sound gets diffused and it is spreading in all the directions, do you think I will be able to hear it properly? What happened? Hello?
Ma'am, read.
No, I asked you a question. I did not get the answer. I said, do you think we will be able to hear it properly if it is spreading in all the direction?
No, ma'am.
Did you hear me saying the same thing before? Or you heard me now? So I just don't want, I mean, I'm wondering whether I'm able to reach you or not. For so many times I'm repeating the same question again and again. Still I don't get any answer. Yes, read.
Number 2. Doctors listen to sound from the human body through a stethoscope. The sound of heartbeat reaches the doctor's ear by multiple reflection.
Now, doctors put the stethoscope on your chest, remember? And that on the left side and
Yes,
sometime on the back also, just to find out that whether you have bronchitis or not. Because he asks you to breathe, deeply. So he can hear the wheezing sound in the lungs. And then if there is no sound, that means you are not suffering. If there is sound, yes, you have got bronchitis. That's what he says. So what they do, they are using the stethoscope. Why are they using the stethoscope, beta? Because heartbeat is very clear, but to make it amplified, to make it magnified, they use stethoscope. So when the doctor puts the stethoscope in his ears, he can very well say whether there's some wrong in the heartbeat or not. Okay? Whether I've got a high BP or not, he comes to know. So how does it reach the doctor's ears? It reaches by multiple reflection. Where else we get the multiple reflection? Let's see. Read.
generally the ceilings of cinema halls
Ceilings.
and auditoriums are curved so that sound after multiple reflection reaches all parts of the whole. Sometimes
Hall.
a hall, sometimes a curved sound board is placed behind the stage so that sound after multiple reflection spread evenly across the whole.
So if at all you go to cinema halls or any auditoriums, the ceilings are generally curved, it's like a dome shaped. It's not flat, but it is dome shaped. You know what is called dome shape? When you go to a masjid, when you go to a temple, temple is triangular shape. And in masjid, it is a dome shape. It is semicircular. Have you observed that? Hello?
Yes, ma'am.
Yes. So that is called a dome shape. Okay? This shape is
Yes.
called as a dome shape. I will just try to show you this shape. This is called a dome shape. Semicircle, yes or no? Right?
Yes.
Okay, fine. So, why is this so? Because the sound after multiple reflection, it reaches all parts of the hall. And also, when you are doing some play on the stage, at the back or behind the stage, we have a curved soundboard. It's kept specially for that purpose so that the multiple reflection of the sound it's spreading evenly across the hall and we can hear it properly. We can enjoy the play in a better manner. Because if the sound gets diffused, we won't be able to hear the conversation, the dialogues properly. You understand?
Yes, ma'am.
Now, this is the megaphone. This one is the megaphone. This is the trumpet, right? And this is the stethoscope.
Stethoscope.
Understood? Yeah. Understood, all of you?
Yes.
You want to do something regarding sonar. It's not in the syllabus, remember that. But I am giving you some extra information for your ninth standard. So ninth standard, it is concerned with sound. And purposely I have introduced it so that when you go to ninth standard, uh, things will be very easy for you to remember. Okay?
Yes, ma'am.
Please start. Start to read.
Sonar. Sonar stands for sound navigation and ranging. It is a
Ranging.
device which uses ultrasonic waves to measure distance, direction, and speed of the underwater object.
Now, sonar is what? Sonar is the abbreviated form of sound, navigation, and ranging. Sonar stands for, that means sonar is the abbreviated form of sound, navigation, ranging. Now, it is an instrument, it is a device which is using which waves? Ultrasonic waves. Which waves it is using with the ultrasonic waves? What do they want to find out? They want to measure distance. Main is they want to measure distance. Where is it going? That is direction and the speed of underwater objects. So, with sonar, what you observe? The distance, the direction, and the speed of underwater objects are observed with the help of sonar. Is it clear?
Yes, ma'am.
Yes. Now, what sonar has? Let's see. How does it do it?
Sonar has a transmitter and a detector installed in ships. The transmitter produces ultrasonic sound waves which travel through the water and after striking the object
Okay,
in the seabed is refracted back to the detector.
fine. Now, what sonar has? Sonar has a transmitter which gives out waves. These are the waves, right? And it comes to the ocean floor or sea floor. And from here, it gets reflected. Agree? So, this
Yes,
is
ma'am.
transmitter and this is detector. You understand? So transmitter transmits the waves and detector detects the waves. It receives the waves, the reflected waves. This much have you understood?
Yes, ma'am.
Yes? Okay. So what is transmitter doing? The transmitter is producing ultrasonic sound waves which is traveling through the water and then it strikes the object in the seabed and is reflected back. So it is transmitted and it is reflected back. And who picks up the waves? The detector or the receiver. You understood? Hello? Did you understand or not?
Yes, ma'am.
Okay. Then what will we do? Start.
The distance of the object can be calculated by knowing the speed of the sound in water and the time taken between the transmission and reception of ultrasound.
Now, this distance of the object you can calculate by how? By finding out the speed of water, sorry, speed of sound in water and the time taken by the transmission and the reception of ultrasound. So we know two things. First, we know the speed, and then we know the time taken. So the ship, the transmitter knows how much time it took to come down and how much it took to be received. So the time is known, right? And the speed is known. Speed of sound in water is known. You can find out the distance. Can you find out the distance, Vita? If the time and speed is known, you can find out distance? Yes, because we know that velocity is equal to distance upon time, isn't it? What is the formula? Velocity is equal to distance upon
On
time.
time.
Yes. In this case, distance is double. The distance is double. Where this is one distance, this is another distance. This is so in all how much is the distance? 2d. Agree?
Yes.
So velocity is equal to 2d upon time. Yes?
Yes, ma'am.
So I can say that 2d is equal to v into t. So d is equal to V into T upon 2. So we got the distance. Easy? Is it easy, beta?
Yes,
This
ma'am.
is how we find out the distance. Okay? Now let's see the ship. It has got a transmitter. You see this transmitter, beta? So the ship has got a device which is a transmitter. What it is sending? It is sending the ultrasonic waves down. Can you see this arrow? So it is going down. It hits
Yes.
the ocean floor. Obviously, the sound gets reflected. Yes or no? And it is
Yes.
received by the detector. It is received by the receiver or detector. Any problem? This is how the sonar works. Any problem, beta?
No, ma'am.
Now, some interesting facts.
Some
Interest,
interesting facts.
interesting facts.
Interesting facts. Number one, sound travels 4 times faster through water than through air.
So what you
Number
understood? What you understood? The sound travels faster in water as compared to air. Did you know that?
yes, ma'am.
Okay. So sound travels how many faster? How much faster? How many
Four
times
times.
faster? 4 times faster. Next.
Number two, there is no sound in space.
What does that mean? Why? Because there is what is
Vacuum.
there? There is vacuum. Because sound needs medium to travel. Which is the medium that we are talking about? Air or water, isn't it?
Yes.
In the
Ge-
space we don't have any air. We know that. So if we speak, the you won't be able to hear if we are in the space. Next.
Geologists use their knowledge of how sound travels through rocks to help them find oil fields.
Okay. Who are the geologists? They are the scientists, they're the researchers who are working with geology or earth science. What did I say? Earth science. So these scientists, they are using their knowledge that how to find out oil fields under the earth. So what do? They send sound waves. They say send sound waves through rocks to find out oil fields. You understand?
Yes, ma'am. Whales in the ocean sing to each other. The sound of their song can travel a distance of 800 kilometers.
How much meter is in 1 kilometer, beta? Yes, how many meters in 1 kilometer?
1,000 meters.
1,000 meter. So you can imagine 8,000 kilometer. The sound can travel if another whale is present at a distance of 8,000 kilometer can hear the song sung by the another whale. You understand?
Yes, ma'am.
It's so powerful. Can you imagine? In the water, 8,000 kilometer in the water, a whale can hear the song sung by another whale.
Yes.
It's funny, but it's true. Okay. Last.
Sound moves through the air at 340 meters per second.
So what is speed of the air? 340 meter per second. It is universal. It does not change. You understand? Sound of air does not change. It remains at 340 meter per second. It is constant, uniform. It never changes. The value never changes. Any problem with that?
No, ma'am.
You want to ask me any question?
No, ma'am.
So we have come to the close of this chapter. Chapter got over.
Yes.
Okay. We'll do
Yes,
something
ma'am.
revision. We have hardly got 10 minutes or so, I think. We have 10 minutes. So
Yes.
just for the revision portion, and please, I will be happy if you give me prompt answer. Okay, I need not ask you again and again. Fine. Let's begin. Can sound travel through solid, liquid, and gases? I repeat. Can sound travel through solid, liquid, and gases? Hello? Can sound travel through solid, liquid, and gases? This is my question. Please answer. Can you hear me, children?
Yes, ma'am.
Answer me then. Why are you keeping mum? Hello? Do you agree or not? Sound travels through solid.
No, ma'am.
It does not travel through solid. You ring the bell. Is it solid or not?
Yes.
Then why did you say it does
Right.
not travel? Just now we heard the whales sing the song. Yes? In the water.
Yes, ma'am.
So sound travels in water. Gas, we are speaking. You can hear me. You are speaking. I can hear you. Air, it is gas. So sound is traveling to everything. Yes. So sound travels through solid, liquid, and gases, all three states of matter. It travels through all three states of matter. Okay? Fine. For human ears, is the audible range 20 hertz to 20,000 hertz? So yes or no? Is the audible range 20 hertz to 20,000 hertz in human? Am I audible? Boys, can you hear me?
Yes, ma'am.
Yes, it is. Is it right? The audible range is 20 to 20,000
Yes.
hertz in humans? Yes, good.
Yes, ma'am.
Unwanted or unpleasant sound is termed as music. What it is called? Unpleasant sound is called as music. Hello. What is unpleasant sound known as? Boys, can you hear me, beta? There's no point in taking revision if there's no answer from your side. Hello? Hello? Hello, Moinuddin. Can you hear me? Mohammed, hello, hello. Boys, can you hear me? Hello, hello. Boys, are you there?
Yes, ma'am.
What's wrong?
Yes, ma'am.
So give me the answer, better. I said, I asked rather, unwanted sound is termed as music. Is it so?
Yes.
Unwanted sound is termed music. You're saying yes. I said unwanted sound. Is it that music? What it is called as, by the way?
No,
Unwanted
ma'am.
sound?
Ma'am, I heard wanted sound, that's why.
I said unwanted sound. So what it is called as?
Then no.
Then no. Then what is the right answer, Vika? What it is called as? Unwanted sound is called as what? So what is the term? What is the name of unwanted sound? Hello? Noise. The name of unwanted sound is noise. Do you get it?
Yes, ma'am. Noise.
Noise. It is noise. Noise pollution may cause partial hearing impairment. Is it so? Noise pollution may cause partial hearing impairment. You agree with it? You agree with it? That noise pollution may cause partial hearing impairment. That means you will not be deaf, but may not be able to hear properly. You can hear only little. Partially you
Yes.
can hear. So it is the answer is yes.
Yes, ma'am.
What is the name of the terminology that suggests the time taken by an object to complete one oscillation? What is the terminology called as? Time taken by an object to complete one oscillation is called, what is it called? Time taken to complete one oscillation is called what? Say, it's called time period. What it is called, beta? Time. You are not revising, it seems. I've given you the question answers also, but still you do not know. Loudness is determined by what components of vibration? Tell me. Which constituent or components of vibration determines the loudness of the sound? Tell me. It is the, see, this is the wave. You agree, beta? And this is the mean. Okay? What is this called as? Can anyone tell me? What is this called as, beta? It's called as amplitude. It's called as the amplitude. Okay, so loudness of sound is determined by the amplitude of the wave, of the sound wave. You got it? You got it, better? And which factor determines the shrillness of sound? Can you tell me? Which factor determines the shrillness of sound? It is the frequency. It is the frequency. This frequency is directly dependent to shrillness of the sound. Remember, the more shrill the sound is, it's unbearable to hear because it hurts your ears. Shrill voice hurts your ears. Got it? And in say in certain ads, uh, during opera, one lady with a glass, uh, when she's singing, it breaks. The goblet breaks. You must have observed these things in
Yes,
the
ma'am.
ad. Yes. So that is called shrillness. Very sharp voice, which is hurtful to ears, and it's so shrill that the glass goblets can easily break. Okay, it can crack also.
Yes, ma'am.
Yes, but you understood, right? So that is called a shrillness. So what ways the noise pollution harms humans, or in what ways noise pollution is harmful to humans? Can you tell me? How does it harm humans? The noise pollution? Can you give me points? What does it cause? Can you give me the first point? Hello, can you give the first point? First is that it causes, what does it cause, Beta? Deafness. You cannot hear. Okay? It causes deafness. Second, it is unbearable. So it causes mental illness also. And third, whenever there's lot of sound, it gives you a headache. Don't you? Don't you get
Yes,
headache? And
yes,
also, the blood pressure may go
yes,
high,
ma'am.
the blood pressure
Yes,
increases, so there will be
yes, ma'am.
increase in blood pressure. So your blood pressure may become high. I hope things are quite clear for this chapter. Yes?
Yes, ma'am.
Fine, I think we are through today's session. We have finished this chapter. We'll start with lesson number 14 the next week. And I will be giving the LQ in the afternoon. Okay? Okay,
Yes,
Vijay.
ma'am. Bye, ma'am.
Have a good day. Bye.
Bye.
Bye.